Hi, good morning, everyone. And this is Balaji from Findability Sciences. And welcome today to the webinar on use of AI in banking application. We will get started momentarily. People are still joining in, so we'll give them 30 seconds and we'll get started. All right. Thank you, everyone, for joining today's webinar. Today's presenter is Anand Mahurkar. He is the founder and CEO of Findability Sciences. And Anand, thank you so much for taking time in doing the presentation. So over to you. I'll stop sharing my screen and you can take it over.
Okay, Balaji. Balaji, can you hear me well?
Yes, we can.
Hey.
Join the meeting.
Balaji, should we start?
Yes, we can start.
So, good morning, everybody. My name is Anand. As Balaji said, I'm the founder for Findability Sciences. IBM declared me as a big data hero 3 years ago. And in addition to that, I was the IBM Watson Partner Advisory Board for 3 years. Before I proceed in terms of sharing with you very interesting technology, its use in the banking applications, and really generally what's happening in the overall banking and use of AI. I would like to talk quickly about who we are. Findability Sciences is a developer of winning product named Findability Platform. It's a big data, cognitive, and AI platform. We are a SoftBank Corporation's portfolio company. SoftBank of Japan has invested into Findability Sciences. We also have formed a joint venture with SoftBank in Japan. In addition, as I mentioned earlier, Findability Sciences was a founding member of IBM Watson Partner Advisory Board.
Join the meeting.
And the ecosystem. We also invested into a Boston-based small startup company which has a interesting algorithm which I'm going to talk as we go ahead. And then we are a global corporation having offices in Boston, Tokyo, Mumbai, and in India. I'm currently joining you from Boston, and again, welcome everybody. We get started with a very interesting quote from William Gibson. I'm sure some of you or most of you have read it or heard about it, but I would like to use this in the context of banking, because with my interactions globally with various banks and financial institutes, typically there are two silos of the banks. Some say we really want to adopt AI, we want to get going, or they have started some initiatives. And some silo people say that, oh, it's still in future, we're not ready, or it's not for us. But what I would like to really use this Mr. Gibson's quote is that future is already here. And I would like to go back almost 11 years in history and talk about and give you glimpses which we generally forget about, that what happened in the market is really impacting us today, and the future is already here. It may not have been distributed evenly in every sector or every continent or every region or every state, but it is already there. And with that, I would like to get a little bit of a flashback memory of 2007. To us as a technologist at Findability Sciences, this was the most important year. In fact, I say that Findability Sciences as a concept was conceived in this year because of very interesting things happened in the market, which when I mention, you guys will start recollecting and probably agree with me. The first and important thing happened in 2007 was iPhone was launched. Now, when iPhone came into the market, that was a future that was there. Most of us got into it personally. It's a good device for a personal usage, but over last 11 years, it has made a serious and huge impact onto businesses. And some of the banks representatives who are on this call would agree with me that the way the banking was conducted has totally changed. Facebook came in late 2006, started gathering momentum in 2007. Twitter was launched in 2007. Hadoop, one of the open source big database which we use in our technology, was launched in 2007. GitHub, which I'm sure some of you tracked just a few weeks ago, got acquired by Microsoft, started in 2007. Android as an operating system came to life in 2007. Airbnb, which changed the entire hospitality industry, came to life in 2007. Google purchased YouTube in 2007. Intel went off silicon. I can just keep going on. What I really want to emphasize that this 2007 year really had some interesting innovation, changes in the market, changes in the landscape, which is impacting us as of today in June 2018, and particularly in the banking industry. How these 2007 changes are impacting, we'll come to that. But I would like to define 2007 as a historic year, and would like to repeat again that I wish if we would have been on this webinar in 2007, we'd have thought that there's no impact, future is not yet here, but future was already there in 2007. Let's fast forward in 2011. Again, a landmark and historic thing happened in technology, and I'm sure all those banking representatives on the call must have heard or read about it, but IBM launched the technology named Watson, which won the Jeopardy show hands down. And this was really a big moment, and you can add any adjective to define that moment, but really changed the technology industry. We at Findability Sciences, we represent almost 99% of our team members are technologists. It changed our careers. It changed the way businesses operate. Not necessarily just use of Watson, but the whole idea that a cognitive technology can do much more than what humans can do. And that started percolating, and many other technologies came. But I would like to call again 2011 as a landmark year where history happened. And again, that time there was a future. We all thought it's still not there. It was just not evenly distributed. Moving ahead in 2013, Findability Sciences started taking a shape from a big data company to cognitive and AI. And as I mentioned, we were one of the early adopters of cognitive technology and represented on a world stage what we do. 2015, some of the examples I'm taking are not Findability Sciences examples, but I'm just taking examples to share with us, you all, our thoughts on what happened in banking. In Japan, Mizuho Bank adopted Pepper. This is a humanized robot from SoftBank, and Mizuho started using it. It made a lot of world news. If you those who are representing banking sector on this webinar, if they have not heard or seen this, I highly encourage you guys to search on the web and look at how Mizuho in Japan is using SoftBank Pepper to do the customer service in branch. So when you go into a branch, you are being welcomed by a humanized robot. Similar thing happened in the same year, a different robot, different manufacturer, but in a country like India, one of the leading bank named HDFC Bank got a robot, and you can see it's a humanized robot as tall as about 6 feet. And now the HDFC branches are automized, where the customer service when you enter into the branch is done by robots. Now, for me, again, being from the native of India or originally from that country, this is very interesting because it's a 1.2 billion people country. There are a lot of people who are providing customer service. Still, a banking organization and a leading bank, probably number one, number two bank, decided to have humanized robots to provide customer service. So again, future was there in 2015, it just not evenly spread. And if you see in United States also now, there are many banks who are coming up with interesting AI application and its usage. I would like to come to now what's really happening in last 6 months in 2018, and would like to take one example, which is very latest launch, which again, most of you have seen it, is Erica. Bank of America has launched Erica now, where you can practically do the banking transaction by either typing into your phone or talking to your phone. Now, this is going to change fundamentally one of the oldest bank of United States, how they operated, how they dealt with its customers. I would like to take a pause and see, Balaji, if my audio is still clear, because I just got a prompt that my internet may be unstable.
No, we can hear you.
Great. So 2018, and this is one of the, again, there are many things happening in the banking industry, but I'm just picking a couple of examples to illustrate what we would like to show you as we go forward. The another example I would like to share, and this is our own example, that Findability Sciences just launched for Aviva Insurance. Now, this is not necessarily a bank, but as a financial institute. We just launched a few weeks ago, Alicia. Alicia is now a humanized, interactive chat, or we call it as a conversational computing, where practically it can create your policy proposal and email it to you without really any human intervention. So a classic example of natural language, classic example of AI, and in 2018, now the insurance companies, which traditionally was handled through insurance agents, have changed. And I'm very happy to share with you that this is a Findability Sciences example where we have deployed AI for providing customer service. Now with this, what's really happening, and why I wanted to take you on a journey from 2007 to 2018, that
join the meeting.
Every year, some landmark things happen in the technology world. But there are really three major things as of this year or as of in the recent past impacting the way businesses are being conducted, not necessarily in the technology world alone, but how technology is adopted and how it is used. And when you see this, there are actually two reasons which are totally different than the technology world. The first is that the market globalization. It's rapidly changing. As you all know, that the technology is boundaryless. There is no region, there is no country, there is no nationality to technology, and the market is really getting global. The second is that the mother nature. Now, there may be debate on this, but if you practically see how the businesses are getting impacted from mother nature, there is a dynamic change and dramatic shift into the mother nature behavior. The weather patterns, the storms, the disaster recovery, whatever is required because of the mother nature is dramatically changing. And the last is the Moore's law. And what Moore's law stands for is that it's an observation that the number of transistors used on an integrated circuit is doubling every 2 years. So it has doubled over last 20 years, and now we can just imagine that it's doubling every 2 years. So on a chip, we can put on a circuit board, we can ramp as many as chips and increase our computing power. As you may be knowing, and I popularly give the example that the iPhones or the Android phones you have in your hand has at least 100,000 times more capacity than the computer which was used to send humans to the moon on Apollo. So we are now carrying a computer in our hand which has 100,000 times more capacity in that computer. So this change has happened basically because of the Moore's law or the observation on that. But what's really happening because of these three things? The first thing happening is the power of one. The individuals can practically do anything. Because of computing power, because of globalization, one person can sit anywhere and practically do whatever possible that it can. The many also can do many things. The group can come together and do many things. The third is the power of flows. The opinions are moving fast. One institution does something, the second institution expectation increases. Like, for example, the Bank of America consumers are now going to get used to using Erica, and they would expect now similarly from every bank to have that facility. We are seeing with our customers like Aviva Insurance, the insurance company is providing something. They want now these opinions to flow very fast and expect new things from their own brands. The last, which is why I highlighted in red, is really impacting in the technology world and even onto the financial institution, is the power of machines. Now, power of machines is where now machines can have 5 senses. A machine can read, can smell, can see, and these 5 senses, which are human senses, which is the last thing which is very interesting, is machine can now think. And with this, practically every business, including banking, is changing. And therefore, I propose and I highly recommend to our customer that it's a time now that for us to handshake with technology or the changing technology. And that combination is what is going to keep your advantage in the market and make your businesses more efficient, more productive, more cost effective, and increase your customer base. So on this note, I would like to share with you that when we talk about AI, or when we talk about cognitive systems, or when we talk about data systems, there are few important items I would like to highlight here as to what is that and why it is, how you should define. The first is that the technology should understand, like humans do. When we meet each other, we talk to each other, there may be very, very sporadic references of something, but our brain can understand and can illustrate what each other are talking. The second is the reasons. Once I understand is, can I extract the ideas from that? And that's what human brain does. The third is that from past results, can we learn? And last but not the least, once we learn it, can it interact? Now, if a machine, or if a software, or if a computer, or if a robot can understand, reason, learn, and interact, that becomes a typical artificial intelligence or AI technology. Now, these 4 points are important to understand, because the human-like interaction, the first point and the last point, is what really changing the banking industry, like what I showed you in Aviva case, or if you take Bank of America, or what I explained to you, what happened at Mizo or HDFC Bank. The reason and learn is really more back-end operations, where if I have some historic data, if I have some past results, can I learn from those? And now, because of the increased data, that learning by humans is really difficult, because if I just take a spreadsheet or an Excel sheet, and if we ask some analyst or a data scientist to study and remember, you can't remember more than 4 to 5 variables. There is a financial institution with whom we work. They have more than 7,000 variables for their customer data. Now, when I'm talking about variables, I'm talking about the columns of the data which is associated with a transaction. So if I want to learn from the past results, it is humanly impossible to deploy manpower and understand from it. So if the machine can start understanding the history and can extract the ideas that really somebody is a loan defaulter because not that that person's credit history is low, but that person's behavior is like this. So if I can extract those ideas, there will be a new way of doing business. And we have proven to many of our customers that extracting these ideas by a machine can practically revolutionize the way they conduct the business. So here is what a platform which can actually do all those 4 things. And I would like to highlight for you that this platform is for business users. You really don't need much technology knowledge. You really don't need large IT system implementations or IT teams involvement. And in addition, as you may have heard in the market, that the requirement of data scientists is also not required for the Findability Platform. So what is Findability Platform? I'm going to very quickly run you through the architecture, and then we're going to go into a live demonstration, because again, seeing is believing, that you can just click 5 buttons and you can practically do the business outcome analysis for your businesses. So in this platform, the first layer is a big data layer. Now, what does big data layer do? Is it collects data from multiple sources. Now, again, we know traditionally the banks, you all feel that your data is secure, your customers have data only within the bank. But you would notice as we explore more use cases, there is a lot of data lying outside the traditional banking transaction systems, which can be very useful for your analytics or your decision making. And therefore, the first layer is very important. Again, it's optional, but we do connect to internal, external, structured, unstructured data and bring it into the first layer. Just taking just an example, I can have a banking transaction. If I am trying to predict if somebody is going to default a loan or if there is any risk on a transaction, I can connect to that person's external data like Zillow.com and find out the net worth or the wealth indicator in terms of the property value. Now, once I have this big data unified, the next layer is a cognition layer, where we can now analyze the text. If some customer has written you an email, or some customer has done a chat with your agent, or if there's a phone call transcript, all that can be analyzed through the platform and can get a natural language interface like what I explained to you at Aviva Insurance, where at this layer, your customer can interact with the system and get their questions answered. And then the last but not the least layer is the AI layer, which has three components. The first is the self-learning component. So the historic unified data goes into the system. And as I explained earlier, that the historic data understanding is important for machine. We can feed last 3, 4, 5 years of data, and the systems can develop models based on that. So once we develop multiple models, and I'm going to explain you actually while we are giving you the demo, that how it develops multiple models, and then it predicts the outcome, and it's all automatic. There is no data scientist or nobody required to manually adjust any of this data. The system does end-to-end automatically, giving you output, which will be typically saying, okay, watch a customer, there is a 90% risk that that customer may be doing fraudulent transaction, or on loan defaults, or there can be many use cases. I'm going to run you through 1 or 2 sample use cases. So what happens in banking industry, and I'm taking consumer bank as an example for now. We do work in the corporate banking and B2B layer also, but just to illustrate and explain, if we take the consumer banking example, as I illustrated in my earlier chart, that if you take a consumer, there is a lot of content being created by that consumer. It's structured, unstructured, social media, public domain, or Internet of Things, any sensors you are putting in the bank, all that data can be collected and now unified for a person. And once you have that data and you run through a technology like Findability Platform, really the opportunities are enormous. For example, you can do risk or fraud detection. You can automatically, these machines can guide you whether the loan should be approved or not, or will somebody default on the loan. You can understand customer churn. You can create now target customer when you are launching new products, or if you are expanding your business on a product, you can get a very high accuracy target list from the system. You can build customer personas. This persona is a completely new revolutionized idea for marketing. If you are trying to get new customers through your digital advertising or digital marketing, having customer persona will help you tremendously than the traditional just demographic data that you have so many males and so many females and so many in this age group or the ethnicity. The customer persona is a new cognitive behavior. And last is the conversational computing. This is really very, very important now, that for financial institutes, their consumers are expecting that they want 24/7 service. They don't want holidays on the weekends. They want to interact with a bank or a financial institute 24/7 and 365 days. So conversational computing, which is typically or traditionally called as a chatbot, can be the application for banking. So having said this, we're going to give you a live demo. We have taken a sample data. This is really a dummy data. We're not taken from any customer. This dummy data is for individuals whose loan applications are in the bank, as just an illustration. And in this technology, there are 2 steps. One is to train the technology through historic data, and second is automatically predict this is the output. Now, what we want to do in the demonstration is we're going to take a training file, which has some few hundred records from the past, and we're going to run that training. Now, once you train the system will automatically silo the data in different silos, create models, and it all happens automatically. Now, after that, we then take a sample subset of the same data and assume that we don't know that outcome, and ask the system that what should have been the outcome, and then compare that outcome with the existing data. That's how typically the tests are done. We're going to run this live system, and then we'll take question answer at the end. So Balaji, I'm going to stop here and hand off to you. I will continue to do the voiceover, but since this is system is on Balaji's laptop, I'm going to stop sharing and ask him to take the control. So Balaji, let's show first the training data, and this is just to explain in terms of how a typical data looks like. Now, again, for demonstration purposes, this is just in data in Excel sheet and shown offline. As I explained in earlier, in the live systems, this data is not seen in this format. It goes directly from our cognition layer or the big data layer directly into the prediction layer. So the first column is really the customer loan IDs. These can be customer names, these can be their customer numbers, and then I will not go through each column, but Balaji, if you can highlight column and scroll it on the right side, you would notice that there are a number of columns in this sheet which are related to a customer. And this is what we call it as variables. Now, for an associated transaction, there are multiple variables. And again, as a sample, we have only few. In the real implementations, we can mix external data, we can mix unstructured data, we can mix any type of data which is coming off sensors, because you don't know if any of those variables you ignored deciding whether the person will default the loan or not. So we're going to train this system, use this file, and Balaji, if you can show the prediction file, which is the subset of this data, which we're going to use it for prediction. And this subset of data, the one requirement is also it should have exactly the same columns. The number of rows can vary based on what you are predicting. In near real-time predictions, there can be only one transaction or there can be multiple transactions, but the columns has to be the same as training. So what you would notice is that the columns are same. What the prediction file will not have is the target variable, or what we are predicting, that column would be blank. So for example, a new loan application comes in, whether that should be approved or not, or that whether that will have risk or not, that column would be empty. When you run that transaction to the platform, the system would then fill that column or field and tell you what it is predicting at what accuracy. So Balaji, let's run these files and show the live demo. So we'll go into the system. So Balaji, if you can log in. While Balaji is typing, this system sits into the IBM cloud. So this is a hosted environment. It is a secure environment. It can connect to, as I said, multiple data systems internally or externally. We want to start a new job or prediction job where we're going to just type, Balaji, if you can start typing. This can be, in this system, you can create in a day 10, 15, 100 jobs. So therefore, we have this option of creating different jobs, or it can be always one job. So we are getting that in the webinar, we are saying loan defaulters, type a description for your future reference, because the system stores all your results. Now, Balaji, if you can stop here for a second, just before you go. I would like to explain this concept. Balaji, 1 minute. We have three options in the system whereby we can model and predict, model and predict. So there are three options. Why it is so is, if I just do what we are going to do now to demonstrate, is we are going to do modeling and prediction together. But now in a bank, suppose once you have matured your modeling and you don't want to waste time now every time in remodeling, because why the remodeling is required is that suppose the predictions go off by a few percentage, the system is a self-learning system. So the data will come back, learn from it, and then again predict. So therefore, doing modeling is recommended, but modeling does take time when there is a large data. So you have an option that you create a model file and every day you just run prediction. So in just few minutes or few seconds, you can have your result out. So at this point, we are taking model and predict. We're going to now browse the training file, pick up the training data set. Now the same file which we showed you, if you see in this drop down, you will see all the columns. So the columns are there, and we're going to tell the system that learn this data based on a target variable, whether there will be a loan default or not. Now, then we do the next pressing the button is we're going to parallelly upload the prediction file, the subset of this data. And then we're going to say on what ID you want to do. So the first is a loan identifier or a customer name or customer ID. So we are now telling the system that get trained onto the training data, and as soon as you are learned is predict on this data. So there are only 5 buttons we pressed so far. We typed the name and description. We uploaded the file, we picked up the target variable, We uploaded second file and we picked up the ID variable. And then we want to press the last button, which is run. Balaji, go ahead. So now the system has started learning. It will show you the messages. And again, it's a short data, so it is for the webinar purposes, we collected this subset. But in literally few seconds or few minutes, it will finish modeling, it will finish prediction, and it will complete the end-to-end job by giving you the business outcomes. So just imagine the power on your desktop, or by the way, this can be run on your handheld devices also. So it can be your iPhone or iPad or a laptop. You can practically create a training file, upload it. You don't need any IT person to work with you, just an Excel sheet, and then upload the data and get the system trained. So the job is over. We want to close it and we want to study the data in terms of what it shows. So this is a out-of-box dashboard. I would like to run through the first modeling part and let me highlight it, what I'm talking about. So this component is where we did 380 records were there in the training data. It developed 38 models in less than 11 seconds. And just for your reference, that typically if you use any other softwares to do the modeling manually or by the data scientist or humans, it can take few weeks to few months for a model to stabilize. Whereas if you've seen here, in 11 seconds, it created 38 models. And in prediction data, we had 120 records, and it predicted all 120 in less than 10 seconds. So Balaji, let's click on to the predicted versus actual, the first dashboard. It's a default dashboard. There is a possibility of giving customized dashboard based on each customer requirement. But this is the standard output you will get from the system. So what this is the predicted versus actual. So there are 103 records which says that the actual was no, that the person will not default, and even the prediction was no. So like that, if you read the entire chart, how many were yes and system predicted yes, and how many were no and predicted no, or where it went wrong as well. So if you can see there that actual was yes and the system predicted no is one transaction, and an actual was no but predicted yes was 9 transactions. So the system went wrong on about 10 transactions out of 380. But again, when I'm saying wrong, it is just binary, therefore I'm saying yes or no is wrong. But it will have an associated probability that it is saying that it will default at 90% rate or 70% rate. So business decision maker can consider the weightage given to the prediction for taking business decisions. Balaji, if you can go to the next tab. So we'll see these models. This is a very interesting concept and a very useful, which again I mentioned earlier, that how the system can provide you the new insights by learning. So the model number 2, M2, was used 83 times in predicting the results of about 120 transactions. So what you can do as a business user, you can study now model number 2 in detail, that why the system picked up M2 and applied to 83 transactions or highest. You can study others also, but typically the business analyst can study this and see what is really impacting on the machine decisions. So Balaji, if you can close this and go to the next tab, please. Is where you can see now the variables, or these are the parameters which impacted on to the machine's decision that why somebody will default or not. Now, this is the most important data business users are going to get, because traditionally there is some wisdom in each institution, and you typically follow that and say that loan defaults are based on only credit history or based on the assets that person has. But now there may be many more indicators the machine can tell you, that more than 3 or 4 variables which humans can think, machine can give you 10 variables or 20 variables and say that the loan is defaulting because of these reasons. Balaji, next tab, please. So these are the models. So Balaji, let's see if we can scroll somewhere and see M2 model, which was used maximum. I don't know whether it is there. Yeah, so if you see in M2, it interestingly used only one variable, and that predicted the highest number of results. But Balaji, if you can scroll above and show the first couple of models where there are more variables being used, that the first time home buyer indicator, the origination date, the loan purpose, the first payment date, property type, and occupancy status, these were the variables which decided the loan should be given or not. So this is very, very interesting for fraud detection or risk analytics. When you are doing fraud detection, now you don't need any data scientist to sit down and study the data. The system can tell you that which model was used and which variables were used into that, so that you can take the business decisions. Now, this is a standard dashboard you get, but on the other side, what you can do is you can download the results. So the entire data you can download, and I'm not going to run through in this, so while you can still download, I'm running short on time. We have 10 more minutes. So we'll just show you the sample. We'll not walk you through each of the tab, but the detailed data can be downloaded. And if you see the tabs at the bottom, you can get all the results, actual, the probability percentages associated with it. You can get decile-wise performance. You can get model details. Balaji, can you expand the sheet, please? Can you make it maximum so that, thank you. You can see which are the critical variable. You can see the model performance. So this data, once you download, can become wealth of your information for managing your business using the artificial intelligence. And again, just to summarize, what we did is we took the historic data, we uploaded, and we said that, okay, now I have the prediction data or I have the new data. Can you please predict what's going to be my business outcome? The applications are enormous and varied. Unlike the earlier software applications where the application was built for healthcare or banking or manufacturing, this platform can be used literally on the fly for a number of use cases. Now, for example, the same data, if I'm instead of predicting the defaulter, if I'm predicting something else, what you have to do is when I upload the data, the training should be done on a new variable. That's all is the change. So from the drop down, you pick up the new variable. The system learns from that based on that variable, creates new models, and does the prediction jobs. So Balaji, at this point, we are 3 minutes short. So we'll stop here and see if we got any questions online.
Yes, Anand, we have few questions that have come from the participant. The first one is, you mentioned about IBM cloud hosting. Can this be done on premise?
So the answer is yes. Our platform can be deployed on premise, and I know that banking regulations or some banks may be conservative to deploy it internally only. We can do that. We don't generally recommend, only for the technology reason that these new systems have ability to expand and contrast based on your data. So if you have large volumes of the data, if you make an investment into physical infrastructure like servers on premise, then you will not be able to scale it down or scale it up very easily. In the cloud, that possibility does exist. However, if some bank wants it on premise, it can be done on premise.
Thank you. There is one other question, and this is a question we get asked a lot, is how much does this cost?
Interesting. This again, when we talk about the AI technologies and we talk about these modern technologies, typically people are concerned about the cost. Balaji, you are right that we get this question all the time. Everybody likes it and they say, oh, it must be very expensive. The cost really varies based on the use case or the amount of data you want, because you guys can appreciate that this depends upon the storage capacity, the computing power we'll need for a use case. But I can tell without any sharing with any specific number, because I can't, not that I don't want to, because it is very specific to use case and data, as I mentioned. So typically the charges are a license plus services, and we charge for per month per server license. And then services is two options. You can, if your technology department can handle it in-house, we highly recommend that they can self-use this system. We can initially help in integrating or implementation. We provide also training. So your own folks can use it. And in that case, there will be no services cost. There will be only monthly license cost. But you can even outsource the, not only the license, but even its use. And we can deploy our resources to run the system. So the charges will vary based on which model you choose, but it's typically per month per server cost.
Right. Thank you. There are a few more questions, but in the interest of time, Anand, I will have to kind of like start talking about like what is available to our banking customers and prospects over here. So once again, Anand, thank you for your time today, and thank you all for joining. But for all the prospects out there, we are providing a free test drive of the platform. Again, on the screen, you will see that it's an award-winning platform. We have been given multiple awards. Sorry?
You're not sharing the screen.
Oh, I'm not. Yeah. So the Findability Platform. It's an award-winning platform, and it's available for a free test drive. So if you need any more information on how you can use it, how you can test it, please send us an email at info@findabilitysciences.com. This presentation will be shared with everyone, and also all the other questions which were not taken up today. We will answer those questions in the email that we share along with the presentation. So Anand, thank you so much again for your time, and thanks everyone for joining the webinar. I hope you found this useful. If you all have any more questions, please do send it across to us.
Thank you, Balaji.
Thank you.